All right, welcome to The Explainer. Today we're diving into something incredibly clever. If you've ever been to a wedding, a conference, or really just any big party, you know the absolute headache that is event photo sharing. You have to hunt down a QR code, download some random app you're literally only going to use exactly once, make an account, and then you have to manually scroll through thousands of photos just to find the 3 pictures you're actually in. And honestly, your eyes are probably closed in 2 of them anyway. It's universally frustrating. But what if you could do all of that seamlessly, right inside an app you already use every single day? Today, we're breaking down how Pixeva completely transforms WhatsApp from a simple chat interface into a highly sophisticated, entirely frictionless engine for sharing event photos. We're going to walk through the exact user experience, and then we'll pop the hood on the cloud architecture that makes the whole thing possible.
Okay, let's lay out our roadmap for today. First, the no-app photo revolution. Second, the host command center. Third, the magical guest experience. Fourth, under the tech hood. And finally, the frictionless future.
Kicking things off with Section 1, the no-app photo revolution, ditching the downloads.
To really understand how Pixeva pulls this off, we're analyzing a super comprehensive technical document straight from their engineering team. And this quote right here sets the perfect stage for our goal today. One file, every detail. We are going to unpack a massive technical backend. We're talking API endpoints, Lambda functions, message queues, the works, that ultimately results in a perfectly simple chat interface for the end user. It's honestly a masterclass in hiding complexity. By constraining everything to just a conversational text interface, they've completely eliminated the learning curve. You don't need to learn a new UI because the interface is literally just a conversation.
Moving right along to Section 2, the host command center, managing events via text.
So the very first thing an event host has to do is link their WhatsApp to their Pixeva account. And this setup flow brilliantly highlights their commitment to zero friction. First off, there are absolutely no passwords here. The host just texts their email address to the Pixeva WhatsApp bot. Boom! The backend instantly fires off a 6-digit one-time password using an email service called Resend. The host checks their email, texts that code back into the chat within 10 minutes, and they're in. Account linked. Under the surface, there's a selfie-based database updating the user's profile and securely marking their phone as verified. It's totally seamless, highly secure, and requires zero context switching. You're set up in seconds.
Once you're linked up, the host manages everything through these incredibly simple conversational text commands. If they type new event, a whole state machine kicks in behind the scenes. It prompts them for a name and a date, and eventually spits out a unique invite code. Need to change galleries? Just type switch, and you instantly get a numbered list of all your active events. You can type stats to see exactly how many photos have been uploaded, or check how many guests have checked in throughout the night. If you need to cut things off, typing pause instantly blocks guest access by deactivating that event in the database. And honestly, this is probably the most useful feature. Say a host just dumped a massive batch of like 50 or 100 photos directly into the chat. They just type done. The system then tallies up all the successful uploads, checks to see if anything failed to process, and hands back a neat, clean summary right there in the thread. So the host is basically manipulating a highly complex database structure entirely through everyday chat commands. It's wild.
Which brings us to Section 3, the magical guest experience, getting photos instantly.
For the guest, it all starts with an invite code. And what's really interesting here is Pixeva's obsessive attention to UX design. They engineered their 8-character invite codes to explicitly omit any visually ambiguous characters. So there's no capital I, no lowercase l, no letter O, and no numbers 0 or 1. Just imagine a guest at a super dimly lit wedding reception trying to read a code off a little printed sign on their table. This tiny technical constraint completely eliminates that frustrating moment of mistyping the code just because you couldn't tell if it was an O or a 0. It's a remarkably small engineering detail, but it yields a massive win for the user experience. So what does the guest actually experience on their end? It is incredibly intuitive. Step 1, you just text that highly readable 8-character code to the WhatsApp bot. Step 2, the bot replies asking for a quick selfie. So the guest snaps a clear, front-facing photo of themselves right there at the party. Step 3, almost like magic, the bot replies with exactly the photos from the entire event gallery that feature that specific guest. These get delivered directly into the chat in nice, digestible batches of 10. There's no hunting through hundreds of group shots, no swiping through some clunky web gallery, just instant, personalized delivery. Oh, and if the event settings allow for it, guests can even just type download all to kick off a high-res bulk zip file generation.
What we really have here is a single chat interface acting as 2 entirely different applications. Think about it. Host commands are all about deep management and database state control. Guest commands, on the other hand, are entirely focused on rapid retrieval and simple navigation. The Pixeva backend is essentially acting as a highly intelligent traffic cop. By constantly checking the phone number against the current session state data stored in Superbase, the system knows exactly who is interacting with it at any given millisecond. It dynamically routes the menus, the permissions, and the available commands based on that, so guests never accidentally see host tools, and hosts always retain total control. All right, time to look underwater at the iceberg. Section 4, Under the Tech Hood, AWS Architecture and Pipelines. Okay. Picture this. A host dumps 50 high-res photos into WhatsApp at the exact same time. If the system tried to process all of those synchronously, it would instantly crash, or at best cause a massive timeout error. To solve this, Pixeva relies on a highly decoupled cloud architecture. Every single message hits an API gateway and triggers the main Pixeva Lambda function. But crucially, it doesn't try to process the photos right away. No. Instead, it extracts the media ID and fires a background job off to an SQS queue, a simple queue service. Think of this queue as a massive waiting room, safely holding on to those jobs. Meanwhile, a completely separate Lambda function, the consumer, quietly pulls those jobs from the queue and processes the media one by one. This decoupled design is the secret sauce, ensuring the WhatsApp chat stays incredibly snappy and responsive for the user, while all that heavy computational lifting happens invisibly in the background. But there is a pretty major catch when dealing with webhooks. Meta's Cloud API guarantees something called at least once delivery. Because of, minor network blips or connection drops, Meta might occasionally send the exact same message to the Pixeva backend 2 or 3 times, just to be safe. If left unchecked, that would be a total disaster. To handle it, Pixeva built a brilliant rolling 50 ID deduplication buffer. Before any message is processed, the system checks the incoming message ID against the last 50 messages stored in that user's session state. If it sees a duplicate, it just silently drops it. This elegant little solution prevents a guest from getting the exact same batch of matched photos 3 times in a row, or a host from accidentally double uploading an entire album. Processing the media itself? That's a literal race against the clock. Meta enforces a really strict 10-second timeout on their webhooks. Basically, if your server doesn't respond in that 10-second window, Meta assumes you're dead. So, Pixeva draws a hard line. They strictly cap media downloads to just 8 seconds. When a guest sends a selfie, the system instantly grabs it, trims it down to a maximum of 5 megabytes, and forces a strict JPEG conversion at quality 92. Why so incredibly specific? Because it needs to perfectly prep that image for facial recognition without wasting a single spare millisecond. And if the image is blurry, or too dark, or just empty, it doesn't sit around waiting. It immediately throws a no face detected error back to the user, prompting them to try again right away. Once we have that perfectly formatted selfie, it gets securely handed off to Amazon Rekognition. This is the heavy-duty AWS machine learning service that acts as Pixeva's core facial recognition engine. It checks the guest selfie against the specific event's entire photo collection in rapid, parallel batches of 100. But it's not just looking for a loose match. It demands a strict confidence threshold of 70, meaning the AI has to be at least 70% confident that the face in the event photo is actually our guest. That 70% mark is the absolute sweet spot. It's high enough to prevent false positives, so you aren't getting photos of some stranger who just vaguely looks like you, but it's low enough to still catch you if your head is turned slightly to the side in a candid shot. Once all the matches are confirmed, the backend separates these standard photo IDs from any video IDs, getting everything prepped for final delivery. And the final step is getting that media back into the guest's hands. Here we see some highly intelligent delivery routing. For standard photos, Pixeva leverages Cloudflare images. It is lightning fast, it converts images to WebP formats on the fly to save bandwidth, and it's globally cached. But if a guest matched with a massive video file or requested one of those bulk zip file downloads, hitting those Cloudflare file limits would cause the download to fail. So for the heavier stuff, the system dynamically switches tracks. It generates secure, temporary S3 pre-signed URLs directly from AWS. The guest just clicks a link right there in WhatsApp, completely oblivious to the complex routing happening behind the scenes to ensure their download is seamless and never, ever fails. Finally, wrapping up with Section 5. The frictionless future, reimagining software interactions. By burying complex AWS architectures, machine learning engines, database states, and dynamic file routing behind such a remarkably simple chat interface, Pixeva proves a really important point. Users don't actually want to learn your new UI. They just want your service delivered where they already spend their time. So, it really begs the question, How many clunky, single-use apps do you have sitting on your phone right now that could just be replaced by a smart, well-engineered WhatsApp bot? It definitely makes you rethink what frictionless software truly looks like. Thanks so much for joining us on this explainer, and we'll see you on the next one.